Hello again. Today's lesson is on section 6.4. It is titled The Quadratic Formula. And so far we've been very lucky that every quadratic equation that we've looked to solve has either been, we've either been able to solve it by graphing or by factoring. And sometimes it's not very easy to factor, or it's not possible to factor within the integers. And that makes solving by graphing as an alternative next to impossible. What we need is a method that is absolutely guaranteed to work. And I throw out the example x squared plus 9x minus 11 equals 0. No matter what you do, you can't factor this within the rational numbers. So we need a different method. So sit back as we derive a very useful, always usable method. And what we'll do is we'll start by playing around with standard formula. Recall that standard form is ax squared plus bx plus c equals 0. And factoring becomes a heck of a lot easier if we do not have a leading coefficient other than 1. So if we can make a equal to 1, then we're in great shape. And we'll do that by dividing the term by a. Ax squared divided by a is x squared. Bx over a is b over a times x, and c becomes c over a. 0 divided by anything that's not 0 is still 0. That didn't change at all. And I've got a method in mind, and I want you to follow, to trust me on this. We're used to solving by having 0 as one side of the equation. I want to get rid of that for a moment. I want to move the constant term over, and I'll do that by subtracting c over a from each side. And that means that the right-hand side becomes negative c over a, and the left-hand side just has x squared plus b over a times x. So here's that last line again from the previous slide, and I'd like to get this into something that's quote-unquote factorable. And so I'm going to pick a number, and I'll explain another time if you're interested why I've chosen this number, but I've taken the values of a and b, and I've decided to add to the left-hand side of the equation b squared over 4a squared. And this number has some very special value that you're going to see in the next as I advance to the next line. But just take it on faith that this is the number that we want to add for right now. I've chosen b squared over 4a squared. And if I add something to the left-hand side, I better add it to the right-hand side as well. So what is so special about this quadratic that we have over on the left-hand side now? What's so special about x squared plus b over ax plus b squared over 4a squared? Well, the magic is that this factors. And not only does it factors so that the two binomials are the same. It factors as x plus b over 2a times x plus b over 2a. And if you want to verify that that works, you can FOIL the last line and you'll get back what's above it, the left-hand side on the second line. I haven't done anything to the right-hand side in this step. I just factored and played with some grouping here. Now I'm going to adjust the right-hand side a little bit because it's going to be a whole lot easier to do the rest of our work if we have one rational expression, if we have one fraction. And that fraction is going to be b squared minus 4ac all over 4a squared. I got a common denominator, and I did that by multiplying the first fraction, multiply the top by 4a, multiply the bottom by 4a. Don't forget the fact that there's a negative sign in here. And so we've actually slid that negative 4ac part to the second half of the numerator. So now on the right-hand side, we have b squared minus 4ac all over 4a squared. And how do we undo the fact that something has been squared? We unsquare it. We take the square root. So if we take the square root of the left-hand side, we're just going to be left with x plus b over 2a. But when we do that, when we square root to get rid of something being squared, we have to remember a plus minus. There's a possibility that what was inside the parentheses here was positive, and that the plus part isn't really necessary. It's possible that it was negative, and by squaring it, we made it positive. So that's why we have the plus minus symbol. That's what this is right here. So we have plus or minus square root of b squared minus 4ac all over 4a squared. And we're going to clean this up just a tad. We'll take square root of the top, square root of the bottom. Square root of the top isn't really going anywhere. We have b squared minus 4ac. The square root of 4a squared is 2a. And we are so close to the finish line. We are so close to the formula. All we need to do is subtract a b over 2a from both sides. And we have reached our target, the quadratic formula. This is the big thing. This is the story of the day, that for any quadratic equation in the form ax squared plus bx plus c equals 0, then we can find the solutions, we can find the x's by knowing what a and b and c are and plugging them into this formula that you see on the screen. X is equal to negative b plus or minus the square root of b squared minus 4ac, and that entire numerator is over 2a. Please note that the fraction bar starts with the negative b and goes all the way across to the end of the radical, that this entire thing is what's being divided by 2a. And this is a super, super, super duper important equation, to the point where in some parts of the world it is referred to as a midnight formula, because you are expected to know this back and forth. I don't necessarily expect you to know it backwards and forwards when you're woken up at 2 o'clock in the morning, but it doesn't hurt to know it instead of having to look it up later. Let's put it to use. We have x squared plus x equals 6. And if you figured out that we need to have the 6 move over to the other side, you are correct. So we need to manipulate this to say x squared plus x minus 6 equals 0. And this is easily factorable, by the way. We can factor this to say, getting ahead of myself here. Let me erase that. And we'll write that again. X factors as x plus 3 and x minus 2. And we know that we should be getting negative 3 and positive 2 as our answers. And in fact, I'm going to write that up here as kind of a marginal note so that we know that's where we're headed. And I'm going to get rid of all this stuff, so I got some... I don't want to get rid of that first line, though. I'm going to have to rewrite that. So let's get rid of all this stuff and start the process again with x squared plus x minus 6 equals 0. We know that a is 1, that's the coefficient on x squared. We know that b is 1, that's the coefficient on x. And c is negative 6. So we'll plug in. We'll say that x is equal to, we start with a negative b. Well, if b is 1, so we have negative 1, plus or minus square root of b squared, b is 1, minus 4 times a, which is 1, times c, which is negative 6. This whole thing is going to be over 2 times a, or 2 times 1. So what we have is negative 1 plus or minus, do a little simplifying here, 1 squared is 1, 1 minus 4 times 1 is 4, times negative 6 makes negative 24. And 2 times 1 is 2. So we're well on our way, and we'll clean this up one step further before I start with a new screen. Negative 1 plus or minus the square root of 25 all over 2. So we'll continue with a fresh page now. We have x equals negative 1 plus or minus square root of 25 over 2. And we know that the square root of 25 is 5. So we have negative 1 plus or minus 5 over 2. And at this point, there's two possibilities. X could be following the plus root, or x could be following the minus root. And as we evaluate these, Negative 1 plus 5 is 4 over 2, and that makes 2. And that's one of the solutions we just talked about. The other solution is negative 1 minus 5. That's negative 6 over 2, and that's negative 3. 2 and negative 3. Quadratic formula has verified for us something that we just did by factoring. Give this one a try. It's x squared minus 7x equals 18. First off, we need to move the 18 to the other side, so we have we have x squared minus 7x minus 18 equals 0. And that means that a is 1, and that b is negative 7, and that c is negative 18. And we'll drop the pieces into quadratic formula. That x is equal to negative of negative 7 plus or minus the square root of negative 7 squared minus 4 times a, which is 1, times c, which is negative 18. Big radical. Going to simplify very nicely in a moment. Denominator is 2 times a, or 2 times 1. Negative of negative 7 is positive 7, so we have positive 7 plus or minus 49. Minus a negative means we're adding, so we're going to add something. 4 times 1 is 4 times 18 makes 72. And we have 7 plus or minus the square root of 49 plus 72. That's one big radical, all over 2. 7 plus or minus 49 plus 72 is 121. And so we're off and running here. At 7 plus or minus the square root of 121 over 2, we'll simplify again. We know that square root of 121 is 11. And so our two possibilities are that x is equal to 7 plus 11 over 2, or 18 over 2, which is 9. Or, follow the negative path, 7 minus 11 over 2, that's negative 4 over 2, and that's negative 2. Our solutions are x equals 9 and x equals negative 2. At this point, you're probably saying, well, I could factor those. What's the value in quadratic formula? Well, the value in quadratic formula we're going to see in an example such as this. We have x squared plus x minus 5 equals 0. And unlike the problem you just did, and unlike the problem we did before that, this does not factor. So we're going to finish with an unsimplifiable radical in it. That's not a problem. The good news is we already have everything in position. We don't have to move a constant over to the other side like we were doing before. We'll just dive right in with the statement that a is 1, and b is 1, and c is negative 5, and my stylus isn't working very well. There we go. So we'll set up, drop things in. We know that x is negative b, so that'll be negative 1, plus or minus the square root of b squared minus 4 times a, which is 1, times c, which is negative 5. And we'll put this all over 2 times 1. We have negative 1 plus or minus the square root of 1 plus 20. Negative 4 times 1 times negative 5 is positive 20. And already you can see the problem that's forming here, because as soon as we combine the terms in the radical, 1 plus 20 is 21. 21 is not a perfect square. Furthermore, 21 doesn't even have a perfect square factor aside from 1. So at this point, we're done. Our solutions are negative 1 plus square root of 21 over 2. That's one of the solutions, and the other one is negative 1 minus the square root of 21 over 2. You can write it as, you can leave it as the radical with the plus minus because there's nothing more we can do with that radical, or you could write them as separate statements. Either way, it's totally fine. The one time when you are not allowed to stop at this point is if you can simplify the radical. When we have rational solutions, take it all the way through, like we did in the last two problems. We didn't stop at something plus or minus a radical over 2. We kept on going. We simplified the radical and then simplified the fraction. You need to do that. Oh, an extra slide that we did not need for that problem. Now we spice it up a little bit. We have 3x squared minus 4x plus 4. For the first time, a is not 1. We'll see how that affects us here. A is 3. And b is negative 4. And c is 4. And I'm going to clean this up a little bit so that you can see that, clearly see that that's a negative. B is equal to negative 4. There we go. And we'll split that off from the c so that we know that we are not combining negative 4 and c. We set up in the normal way. Negative b, so we have negative of negative 4 plus or minus the square root of negative 4 squared minus 4 times a times c. And this is all over 2 times a, but a is 3 in this case. So we'll clean it up, and we have x equals 4. Negative of negative 4 is positive 4. 4 plus or minus the square root of 16 minus 4 times 3 is 12 times 4 makes 48. Maybe you've noticed what's about to happen here. 16 minus 48 is a negative number. So we are saying that x is equal to 4 plus or minus the square root of negative 32 all over 6. Let's see if we can simplify this radical at all. And we know that we can. Negative 32. Well, first off, the negative means we're going to bring an I outside. There is a perfect square factor of 32. It's 16. Square root of 16 is 4. So we'll rewrite the numerator as 4 plus or minus 4i square root of 2 over 6. And we'd be done except for the fact that the 4, the other 4, and the 6 all have a common factor of 2. So we'll reduce all of them by a factor of 2. 2 goes into 4 2 times. 2 goes into 4 2 times. 2 goes into 6 3 times. And we'll finish at x equals 2 plus or minus 2i times the square root of 2. We leave that radical alone, just as we were doing before in previous lessons. 2 plus or minus 2i square root of 2 all over 3. There's your final answer. And again, you can leave it in this form because there's nothing more we can do to simplify this. We're stuck. We can't. We do not have rational solutions here. One more for you, and it's the problem that we started the lesson with. X squared plus 9x minus 11 equals 0. Give this a try. Let's see how you did. First off, we need to identify our values for a, b, and c. A is 1, b is 9, and c is negative 11. So we have x equals negative 9, negative b, so negative 9, plus or minus the square root of 9 squared minus 4 times 1 times negative 11. And the whole thing is over 2 times 1. clean this up a bit. We're saying that x is equal to negative 9 plus or minus 81 plus negative times a negative is a positive, so that's why we're safe with a plus sign. 4 times 1 times 11 is 44. And the denominator becomes 2. And we'll do one more line here. We'll do one more step here before we have to clean this up. Negative 9 plus or minus 81 plus 44 is 125. So we have negative 9 plus or minus the square root of 125 all over 2. So up to this point we have x equals negative 9 plus or minus the square root of 125 all over 2. And there's only one more thing we can do to simplify this, and that's to attack on the square root of 125. Square root of 125 simplifies as 5 times the square root of 5. So our solution, our final answer for x is going to be negative 9 plus or minus 5 root 5 all over 2. There's nothing more we can do in this problem because we can't combine the term without a radical and the term with a radical. It doesn't work that way. And it's also not true that negative 9, 5, and 2 have common factors other than 1. Even pairwise, they don't have any factors greater than 1. And so we're finished. This is the solution. X equals negative 9 plus or minus 5 square root of 5 all over 2. Thanks for watching. We'll be back next time with more quadratic videos.